If I say 1 hour, what's an equivalency unit? 60 minutes. If I say 1 decade, 10 years. If I say 1 foot, 12 inches. Like, we know a lot of equivalencies in everyday life. If I say 1 dozen, 12, like 12 items, 12 bananas, 12 pencils, something like that. So your job is to go through a process of converting from unit to unit to unit to unit to unit. And your job is to go from years to microseconds. Now, do you know that conversion? I don't either. Like, I couldn't tell it to you. But we have a process where we can take one baby step, another baby step, another baby step, and another baby step. So literally, this is unit conversion, which means that we have to be very familiar with a lot of units, which on your intro video, you saw like all those SI units. And then from there, we can even mix it up with some English units, like, you know, how about years? So we'll start with, let's go, Cole, how are you in years? 15. Okay, so 15 years. And I'm going to show you how we can set this up so it just looks clean and we can see how units cancel. So we're going to convert. Who else is 15? All right, so you're not the only one. Okay, so here we go. We're going to take years, and we're going to set up like a little fence post. We're going to use actually like probably 4 or 5 of these. So kind of set this up for yourself first. All right, if your neighbor is not setting this up, get them going here. Snap, snap here. Let's go. Encourage them, positive encouragement. Okay, so here we go. What is the first conversion, or what are the first unit relationships you think of when you hear years? Days. Like, everybody knows how many days are in a year. So I want to cancel out years. Nobody cares about years. Eventually, we want to get to microseconds. So do I want to put the year unit on the top or on the bottom? Bottom, because years and years have to be in opposite areas so we can cancel those units out. So I say 1 year, that's equal to what? 365 days. And we are actually not calculating baby step by baby step. We're going to calculate the whole shebang at the end. So this allows us to cancel out years and years. Done. Years have been taken care of. What is the next unit I want to get rid of?
Days.
Days. So I want to get rid of days. So where am I going to put it? On the bottom, because this day and days and day are going to cancel. Now, what's the next time frame that you're starting to think of? Hours. So days and hours have a relationship. So if I say 1 day, how many hours are there? 24 hours. Okay, what unit will cancel? Days. So you always take the unit on top and you throw it on the bottom of the next conversion to cancel out that unit. So now proceed. Try to get you down to microseconds. Use your logical like time scales that we have. Person needs to be the resource. All right, so I'm hearing hours, and you're going to what next? Hours to minutes. Let's just do baby steps, right? So minutes are going to go on top, hours are going to go on bottom. What are the numbers here? 1 hour and 60 minutes. And then that you're showing your cancellation of units, hours and hours cancel. And then keep on going. What's the unit on the bottom? Minute. And what's the unit on top? Seconds. And then which of these is the big unit? The minute. So one big old unit of minutes contains how many seconds? 60 little seconds. So what you're seeing is that the numbers are going to be changing, but as we're changing the units, it's all going to be still equivalent to 15 years. Okay, so the microseconds comes in. So what do you have to think of here? How the king died, right? So how did he die? Okay, so King Henry died, and then I go lowercase, right? So base by dot dot micro, and then keep going dot dot nano dot dot pico. Okay, so that's our number line for the metric system. It's all based on a 10 scale, so it goes from like, a million, no, so 1,000 all the way to base of 1 to like, a 10th space, and then, or sorry, 10th space, 100th space, thousands, and so forth. So this is a small, small, small unit. So the way you're going to work that is seconds have to go where? On the bottom. So one huge second contains how many little microseconds? So you're going to say 1, put a 1 underneath the base. So that's because that's our second is a base unit because there's no prefix on it. So put a 1 on your base. And how many zeros away is micro? 6, because the dots are placeholders, they do count. So 1, 2, 3, 4, 5, 6. So how many little bitty micros are in a second? How much? 1,000,000. But you know we got time to write 6 zeros. So we're going to write 10 to the 6. Okay, because I don't want to write 6 zeros out and by mistake miss a 0. So that's 10 to the 6 microseconds using S. So that's how you figure out the relationship using the number line system if you have a metric prefix. Okay, so seconds cancel. We are in microseconds, and that is the only unit we did not cancel, correct? So that is the standing unit. So we're going to put equals so many microseconds. All right, so now our job is we can do one of 2 ways. Either calculate the entire numerators by just multiplying across, separately multiply all the denominators by multiplying across, and then take numerator, divide by denominator. Or, in this case, what do you know is all the denominators are? 1. So are they going to impact our overall calculation? No. So let's just roll. Calculate across. So clean your calculator. 15 times what? 365 times 24 times 60 times 10 to the 6. Make sure you know how to use your caret button. Ooh, let me get that in scientific notation because I don't have that kind of capacity here.
I don't have a caret. I don't have
what are these? Your calculator?
I
Maybe, so we have different calculators across the room. Someone next to you should help you with a calculator. I have the numbers in scientific notation.
4.730414.
For some reason, it's not wanting to do my scientific notation. So, does anybody have this in scientific notation?
4.730414.
Okay, I'm taking all those for now, times. I hear 14 power, and that is microseconds. Okay, so you are so old, guys. Look at that. That's a crazy number. Now, the measurement we took of said person, okay, was what? 15 years. All of these other conversion factors were not true measurements. So them being non-true measurements because they're just equivalencies we knew in our head, these are not playing into our sig figs. The thing that plays into our sig figs is the measurement taken. So this was the measurement, which has how many sig figs? 2 sig figs. So that's going to rule our final answer to be what? 4.7 times 10 to the 14th microseconds. Can you imagine if you went to picoseconds? Be super, super old. How many more decimals over would that be? How many? Should be 6, right? Because it's hard to see my dots. 1, 2, 3, 4, 5, 6. So that would be 10 to the 20th, which would be 6 decimals over. All right, so that process is actually what dimensional analysis is. If you understood this, give me like a 1 out of 10 or 5 out of 6. Give me like where you are. Like if you're comfortable with canceling units. Okay. You don't always have to broadcast it. It can be just like right here. Like I'm good with that. Okay, hands down. All right, so what our job today is, and you'll want to pull out your lecture note sheet because we have some problems on there. I like to print you the problems so you're not like squinting at the board and seeing the problem that we're going to print. So our job today is to understand one, I love this one, dimensional analysis, which just sounds like a crazy, like, weird process, but it's called chemistry math. It's just literally chemistry math. So chemistry math in your textbook is called factor label method, but you'll hear me call it dimensional analysis, just chemistry math. And all it is multiplying things across, and as we do that, we are canceling units, canceling units, canceling units. So I'm probably going to go through 5 examples first. And once you get the hang of it, you got to let me know, because I can talk for days and do example problems, example problems, example problems. But as you get the hang of it, I'm going to try to let you practice them on your own, and then you can try to start some of the homework together in class. Okay? So that's my goal. But I have to get some feedback from you, okay? So just FYI, multiplying fractions for the purpose of canceling units is literally all we're doing today. Okay, but we're going to do example problems together. So if you want to write that part down, that's literally what this whole dimensional analysis topic is. So the multiplying fractions aspect, fractions, we know have a numerator and denominator. It's old school, like what, 5th grade math, even learned from that. Second grade math. I forget where I was in math back in the day. The word fraction that is listed here can also be called a conversion factor. And a conversion factor is something that occasionally we'll call an equivalency. So like when I was saying, 1 foot, you immediately thought what? 12 inches. That's an equivalency. I said 1 year, and you immediately thought 365 days. That's an equivalency, aka conversion factor, aka a fraction that we can input in a problem. Okay, so I'm going to tell you that density, which we spoke of yesterday, is simply a conversion factor. And the way you can tell by its unit form that it's a conversion factor is you see the slash. What does that slash represent? Per, right? We always say, oh, this density of aluminum is 2.7 grams per centimeter square, or centimeter cube. So instead of writing the fraction like this, I'm going to always encourage you to write it literally as a numerator and denominator. So write down the density of aluminum is 2.7 grams per, so divide by 1 centimeter cubed. Do I have to write the 1 all the time? No, I mean, we assume that there's a 1 here because there's no number listed, but it truly is saying, if I had 1 little cube of aluminum and I massed it out, it would equivalent to 2.7 grams. Like, that's literally what the equivalency is. So, what we want to show is these are some word problems, and the word problem always will start you off with something. That's something I like to call a given. So write down this given. It's 40.0 centimeters cubed. And notice there's a common unit. What is the common unit between the given and then this conversion factor? Centimeters cubed. So we actually know we can utilize those together because there's some matching units and we can cancel them out as needed. In this question, what is the actual question? What is the unit it wants? Grams, right? So here's the other part of the question. Every single word problem or problem setup will have these 3 things. The given, meaning you start with this. Okay, so this is your starting point. This is like how you interpret a problem. This is your starting point. You'll use a conversion factor or numerous conversion factors. In the problem we just did, we did like 6 conversion factors. This one we're going to use 1. And then we're going to solve for the question, meaning the unknown. You good? So let's set it up. What's the starting point? 40. Keep going. 0.0 centimeters cubed. Right? Do the little bar thing, so the fence line. So I have the power to flip a conversion factor if I can, if I need to. Here's the conversion factor, 2.7 grams per centimeter cubed. If I take this and plop it here, does it serve the purpose of canceling units? Yes. If I flipped it, would it serve the purpose? No, I'd have like centimeters cubed times centimeters cubed, and then I'd have like centimeters to the 6th power, which we've never even seen in our life. So I want to keep it as it is by writing 2.7 grams, because the 2.7 is described by grams, so I have to keep that together, by 1 centimeter cubed. And literally, I have, instead of solving this process by proportion, I can use dimensional analysis. Proportions are like math-style mathematics. We're talking about chemistry, so we actually use dimensional analysis. So the centimeters cubed cancels, and then solve. What is it? 108. Okay, 108, 80.
Oh.
Double check that. No, I like to have everybody calculate so I can get some consensus because Butterfingers, you know, we all slip up sometimes. So 108, and what's the unit remaining? Grams. This is the only unit we did not cancel, so therefore we carry it with us in our final answer. Discuss with the person next to you how many sig figs should be here. Remember, the measurement is the thing we base it off. All right, hold up. How many sig figs? Okay, I see about half the same 3. No, 3 it is.
3.
Because this was the measurement. The measurement is where sig figs kind of get fishy. The measurement was taken to be the volume of 40.0 centimeters cubed. The conversion factor is like a given piece of data in a data table, and it's not really going to be questionable for us. So let's stick with the 3 sig figs and call it our final answer. Always block off your final answer somehow so you know what you're doing. Okay, I want you guys to solve for the second one using dimensional analysis. Solve for this. Use that same conversion factor if you need it. Keep it up. All right, so how are you starting this one math like a setup wise? What you're given? 40.0 grams, right? So this is your given, okay? That's your starting. You're going to do your little dimensional analysis bracket thing. And what conversion factor we plug in? The same one, but we flip it because I can't put 2.7 grams on top because then I have grams times grams and nobody wins. So I put the 2.7 grams on the bottom to show cancellation of grams, and what has gone on top? 1 centimeter cubed. So this is the conversion factor of the density provided above. I didn't just pull this out of the air. So then that's going to allow us to cancel out what unit? Grams, and then that solves to be what? 14 point what? 8. I trust you all. You're my human calculators. 1.4 and some change. Okay. So then we're rounding to how many sig figs? 3 sig figs. So then that's 14.8. What unit remains? Centimeters cubed. Sorry, that looks awful. And that would be our final answer. So in this one, math, in your calculator, all you did was you could do 40 times 1, and then you could divide by the singular denominator here. So 40 essentially overall, we're doing 40 divided by 2.7. Anytime a number is in the denominator, you're dividing by it. Okay, so we'll work on calculations. All right, let me choose the next one that would be our best suit us. Let's do one of these. Okay, so this one's actually given to you in a table. You have all these conversion factors. I am not expecting that you even have any of an inkling or any idea what heat of fusion is and molar mass and specific heat, but I want you to see that. Do you see all these slashes? Okay, slash, 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 slash. Those are the division symbols, which are those conversion factors. Are we clear? These are all conversion factors. Okay, this is also conversion factor. It's just written a little differently. Like if I said 1 year is equal to 365 days, that equivalent thing is just a conversion factor. You can also flip any of these you wish. So, I want you guys to do, let's do this one. I'm just going to pull it up some. So I want you to convert 80.4 milliliters into molecules. So let me tell you your thought process. We want to start with what? The only given we have, which is what? 80.4, right? We have to start with our given. And before you start converting, map out your plan. These are all the conversion factors you can work with. I'm looking for a conversion factor with milliliters and molecules in it. You see one of those? that has a collective milliliters and molecules in the same conversion? No, I don't. So I can't do this in a single step. I'm going to have to do this in maybe 2 or 3 steps. So if you can, with the person next to you, map out your plan and then start trying to process it.
Like 600 billion.
Okay, so we're going to convert it into grams, right? And then after that, we're going to convert it into molecules.
Who feels like they know this? They kind of picked up my puzzle. It's just going to be like a little hand raise. All right, great. So I'm going to go ahead and fill in the gaps here. All right, so eyes back up here in the middle calculating. Let me help you with your putting your dots together. So I see milliliters. I'm looking for a conversion factor with milliliters in it. I only see one, right? So I have to use this one in order to cancel out milliliters. So I have to use this one next. It's the only option I have here. So as I write this one down, do I want to keep it as it is or flip it? Keep it as is, because milliliters is where numerator or denominator in this conversion. It's in denominator. So I'm going to write 0.9994 grams. Okay, so stop your conversations for the moment so everybody has the benefit of hearing what they need to. And that imaginary 1 is describing the milliliter, so that's per 1 milliliter. So this allows me to cancel out milliliters. So I have used this conversion factor first. At this point, I'm still not to molecules, so I must find a way to cancel out grams. So I'm looking for grams, and I see it here, 18.02 grams per 1 mole. Mole, MOL, is not a molecule, so that's why you see that written differently here. So how do I write this one? As is or flip? Flip it, so I want grams where? On bottom. So here we go. 18.02 is the number describing grams, so I can't separate that, keep it together. 18.02 grams per 1 mole, but that 1 mole is going on top for us here. So then our grams can cancel. Notice when I'm canceling the actual unit, not the numbers. The numbers matter. We actually calculate with those. Okay, and then keep on trucking. Now I have mole. Nobody cares about moles. We want molecules. So we're looking for how to cancel mole out. Which of these conversion factors has mole in it? The top and the last. Why do I not care about the top one? It gets to kilojoules. Joule is a unit of energy. Nobody cares about energy. We want the relationship of mole to molecule. So this is the last one we'll use. So 1 mole is equal to blah, blah, blah molecules. So how do I stack this? Do I put mole on top or mole on bottom? Bottom. So 1 mole is equivalent to 6.02 times 10 to the 23rd molecules. And by golly, we are done. Milliliters canceled, grams canceled, moles have canceled, and now the only unit left is molecule. Check. I've made it to the unit I desired. Now I must calculate. So here's what I would be plugging in my calculator. 80.4 times 0.9994 times 1, which is not necessary, times 6.0 times 10 to the, or 6.02 times 10 to the 23rd power. So we only calculated the numerator in that process. So we need to divide by what now? So divide by 18.02, and we end up with 2.684 times 10 to the 24. And that's molecules. Tell the person next to you how many sig figs you need. 3, and then round your answer. 2.68 And I still need to be big, so times 10 to the 24 molecules. Okay. All right, is this crew over here? You guys good?
Yeah.
Okay. How are we doing here? Give me a head shaker, like scared look. I'm like, okay. I'm just looking into your eyes, into your souls. Ryan, you good over there? Okay. We're going to practice a little bit more. So I've actually started you off with the challenging ones to see what you could do, so I could see if you were ready for the rest of this. But the next couple should be more approachable. So I gave you all those conversion factors in that table because I do not expect you to know those until like maybe halfway through the year. Okay, because that's something we'll actually practice. That's something that will become second nature to us very soon. Yeah, so halfway through the year we'll know those. So it's a part of the learning process. Okay. So we're going to skip doing another one because again you'll notice it's just me giving you conversion factors. What I expect you to know is how to convert on a metric scale. I expect that you can say, I have 1 meter, how many kilometers is that? If I have 1 meter, how many meters or how many centimeters is that, and so forth. So let's practice that one more time because we have our little King Henry system, right? King Henry died by drinking chocolate milk. Micro, not the third dot. Micro dot dot, nano dot dot, pico, and then dot dot, mega. So if I say if I have 1 kilometer, how many micrometers is this? Okay, so if I have 1 kilometer, how many micrometers is this? That means you're going to put a 1, and I'm telling your process orally, I'm also trying to write on the board for you, okay? Your first thought is to choose the larger unit. This crew over here has got to stop talking for a minute, because if I say something and someone misses it from this crew and then they get it wrong, it's on you, okay? So choose a larger unit. Is kilometer or micrometer the larger unit? Everybody. Kilometer. So you're going to put a 1, okay? So we did that. Put a 1 on the kilometer. And then you're going to follow up by going 0, 0, 0, 0, 0, 0, 0 to see how many little teeny units of micrometers are in the big unit of a kilometer. So how many, so add zeros until other unit is reached. So how many zeros does it take? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or you could literally just count them. You don't have to put the zeros. So how many instead of writing a billion, what do I want to put here instead? Make it short and simple. Just equal 10 to the 9th power, which means that if there's a billion little teeny micrometers in 1 huge kilometer. So there's always a lot of little things in one big, and that's how we work our number system. So we're going to convert with that now, okay? And this, I think, is where I take it on the paper on the next possible. Is this is on your notes? Yes? On the right-hand side? Okay. So we're going to do just a couple from each subsection because once you get that subsection of questions, you're good to go. I always have extra practice, though, for tutoring or something like that. You want to come and get some more. So in the first one, what's the given? 30, so 3500.0 milligrams. So milli, so that's the M on the number line. Okay, so you're still showing me dimensional analysis. I know you can decimal swoop like a boss, but that decimal swooping is not the skill we're actually practicing. So we're practicing dimensional analysis in easy, familiar situations, so that when we get to unfamiliar situations, you're good to go. So do your little fence thing. What unit do I want to get to? What unit do I want to get to, guys? Gram. So I'm going to go ahead and put gram on top, and what on bottom? Milligram. Why am I putting milligram down here? To cancel. So on the top of your paper someplace, go ahead and write out the little number schematic. Because we are going to use that for the whole class, okay? So what unit is larger? Gram or milligram? How do you know, where's gram out on this scale? It is a base unit because there is no prefix, so that is the base unit. So gram is here at base, and where's milli? 3 to the right, at M, okay? So who's the bigger unit? Gram. So put a 1 on gram, and if we put a 1 on gram right here, how many zeros would it take us to get to milli? 3. So you're saying there are 1,000, how many milligrams in a gram? 1,000. And I'm lazy and I do scientific notation because I don't want to end up writing like a million zeros. So you could also just put 1,000 right there. You don't have to put 10 to the third. So that's it. You're going to put in your calculator 3500.0 divided by what? 1,000. And you should get, in your calculator, you get 3.5, correct? And that's going to be, milligrams have canceled, but it's on top and bottom. And that gives us just straight up grams. Now I'm putting this over here because there's an issue. The measurement here had how many sig figs? 5. 1, 2, 3, 4, 5. Okay, so 5 sig figs. So how would I write the final answer?
3.5000.
So add on some zeros as placeholders. 1, 2, 3, 4, 5. Because now we're super duper accurate at 5 sig figs versus the 2 we had up there previously. Right, work with the person next to you and do number 3. So I'm just going to say this out loud. You should show your work for every problem in this class. And if you're trying to squeeze it on my lecture note sheet, it may not be very organized, so studying might be a challenge. So organize your notes so that you can study from them, okay? Aiden or CJ, can you guys help here? What number? Once I write my units, what am I starting to think of over here?
You want to see how many micrometers are in a
Okay, so why did you say in a meter? So you're saying meter is the bigger or the smaller unit?
meter? Yeah, meters.
Okay, so 1 meter is the bigger unit, and that's what I wanted to go to. How many micrometers are in a meter? A billion?
A million.
A million. So I'm not writing a million. What am I probably gonna write? 10 to the 6. Good. So here our cancellation of units is micrometer, micrometer, and so when you divide by 10 to the 6 in your calculator, what do you guys get? 0, 8, 4, 3, 4, 5, 6. And then what's the unit? Meter, because meter is the only unit left. So instead of writing it in decimal form, can we just do a quick shot at scientific notation? So this would be what? 8.4, 3, 4, 5, 6 times 10 to the negative second. Good. Because we actually have the decimal here, but when we put it artificially behind the 8, it's here. So we back it up 2 spaces, which is negative second meters. How many sig figs are in this problem, or in this answer? Like super accurate, right? There are 6 initially, and there are 6 here in the end. So the metric system is just a conversion process. It is these numbers we're plugging in, like 1 and 10 to the third, or 1 and 10 to the 6th. Those are not playing to our sig figs, because they are not the measurement. Give me a thumbs up when I can move past these 2 questions. Just trying to make sure we're close to the majority of those stuff. Just make sure we're close to the same page here. All right, so those are single unit conversions, 1 unit to another unit. So let me show you this one first, and I'll go back to this other one. So I'm on the complex units. I'm on the maybe like the 3rd or 4th section down. So these are called complex units simply because they have more units than 1. They have 2 or 4 units in this case. So if I want to convert 74, so write out this as a fraction, not with a slash like this, but with a fraction bar, 74 meters per second. I want to convert singular units to the other single unit at a time. So meter is truly being converted to what in the answer? Kilometers, right? Or kilometers. It doesn't matter. Good. So meter to kilometer. So that's my very first thought. The second thought is going to be time. We're taking seconds to what? Hours. But I can't do these two sections at the same time, so I just got to take baby steps. So I'm going to choose to work with numerator first. So do your little fraction bar thing. So I'm going to take the meter to a kilometer first. So what unit do I need to cancel? Meter. Meter is going to go where on this fraction? Bottom. And the kilometer is what I want, so I want to put that on top as it states, you know, kind of to do because it's in the numerator of the unknown. So everybody's looking at their number line. Who's the bigger unit? Kilometers, so we put a what there? A 1. So in one huge kilometer, which is K, how many zeros does it take me to get to meter? 3. So you're saying there's how many meters in a kilometer? 1,000. Or you could write 10 to the third. All right. Done. We have finished the first one. Meter cancels. I'm going to circle kilometer just so I'm aware I want to keep it because it says for me to keep it, so I'm not going to mess with that one again. Now, kind of starting back of the front, I want to get rid of second, correct? Because I want to go to hours. So how do I get rid of second? I put it where? Up top. Okay, so I'm going to put second up top here because it's going to be counter. It's going to be opposites of each other. And I want to go to hours, but it's in the denominator because it's on the bottom side of the slash. So the hour is going to go down here. So you just know that naturally. What's our conversion? 60 seconds an hour? 60 minutes in an hour, or 60 minutes an hour, but there's 60 seconds in a minute. So how many seconds are in a minute? 60 times 60, which is 3,600. Now, I don't have to do that in a single step. I could truly go seconds to minutes, minutes to hours. But this is just another shortcut if you choose to use it. So there's 3,600 seconds per 1 hour, which we just did 60 times 60 in our head there. So what unit cancels? Seconds here and seconds on the top over here, leaving us with what unit on denominator? Hours. Check, check. Kilometers per hour, kilometers per hour. We're good to go with calculations. Starts with a 2. Point what? 4. And that's going to be what units? Kilometers per hour. And going back to sig figs, how many sig figs should I have in my answer? 2. So my initial measurement here had 2 sig figs. So this should be rounded to 2 sig figs, which would be what? Okay, I heard 2s and 7s. I also heard, or just 270. So I want the 2 and I want the 6, right? But I look next door to 6 and what do I see? Another 6. So then this 6 rounds this 6 up to be 27. And then I can't keep 27 and 266 the same. That's like totally different numbers, right? So what do I put after the 7? A 0 kind of as a placeholder to stay the same scale. It's like 270-ish. So that's 270 kilometers per hour, or 2.7 times 10 to the second. That one took maybe a multi-step thought process. Try number 3. I think you're doing great, but I'm not sure, so I'm trying to see like different people where we are. If you're confident, turn around, try to help and check your work with the person behind you or beside you. If you're not confident, also do that. Or let them finish first. All right, I hope that was enough time to process. I try to be respectful of everybody's time requirements, but I also have to watch the majority. Okay, so our thought process was numerator first and then denominator. So you took your what unit first? What unit did you get rid of first? Kilograms. Now you could have done denominator first. I'm not saying you can't. I'm just sticking with the same flow so that if we keep doing it the same way, you can't make a mistake. So kilograms and kilograms were what I wrote first. And I saw that it asked for me to go to kilograms to milligrams. So on my number line, how many zeros away was that? 6. So K was way over here, base unit, and then milli was 3 away. So there's 3 and 3, so that was a total of 6. So that's a million, so 10 to the 6 milligrams. Do I want to cancel out milligrams? Yay or nay? No, because I want it to be here in the end, so I'm not going to touch that. So kilograms have canceled. Great. And then second, it said to go from liters to milliliters, which liter is that, where is that on the number line? It is B, base, because liters, meters, grams, joules, anything with no prefix is base. No prefixes mean base. So liter is base, and milli is 3 away from base. So liter goes on top, which is the weird thing, because it has to counteract. So liters were canceled, and then we had already decided that there was 1,000 milliliters in a liter. So literally 10 to the 6th and 1,000. When you multiply and divide, you get 4.7 or 470 milligrams per milliliter. Which, how many sig figs does the initial answer have? 3. And how many do we have in this answer? How many? 2. So what do I need to add here? A decimal. Now would give me clearance to go. That's 3 sig figs. How could I adjust the lower answer to be 3 sig figs? Add a 0, and that would be 4.70, so there's 3 sig figs across. Okay, so there's 2 different ways you could write that one as well. Okay, you have a quick stretch break, and I have something to request of you. I like name cards so I can pull names, so I can like randomize who I ask for questions from. So I'm gonna have you guys write your name and then some crazy characteristics about you. Okay, so I'm just gonna throw note cards at you. Ready? And you can decide if you have to go see somebody, if you need to see somebody. And then, pass those back for me. Name and 3 cool characteristics about you. If there are extras in that middle row. Name and 3 characteristics. You can get creative on it. Write your name big on one side if you didn't, just so I don't have to squint. It's getting old. I see all of you took advantage of your stretch break. Get up and move. No?
I did.
The one squat, okay.
I already put that.
Alright, now I want you to get up and share your name and 3 characters. I don't want to share those 3 characteristics, but share some characteristics with 3 people. Get up and go.
Wow.
I know, this is your favorite part of the school is sharing.
I don't know if I should be telling you guys. Yeah, that's a dead actor.
Get up, people. You must have plastic seats. Get your backs up. You must move your legs. Breathe. Walk. Breathe. Walk. Get some oxygen. You have to walk around for a minute.
As in, like,
Alright, you have 10 seconds more to make your selections of friends to share with. 10, 9, 8, 7, 6, go back to your seats. 5, go back to your seats. 4, go back to your seats. 3, go back to your seats. 2, pass up your pink card. 1, pass your pink card up and over to Bryce. Gosh, I knew Bryce, I knew it. Pass your pink card up and over to Bryce.
I was given it.
Alright, cool guys, thank you. So hopefully that stretched breath break helps a little bit. Because your brain won't function unless you get some oxygen up there and a little glucose, so chew on gum if you want to eat like pony candies that I can't see because you're a stealthy ninja. Do what you gotta do. Okay, so I don't lecture heavy every day, but today's one of those days. Alright, so I have one more kind of set of questions to show you, just 2 of these, and then we're going to practice some on our own, okay, or with the group. So, this is the 3rd section in your lecture notes, yes? Look at your lecture notes. And this one is fancy because it's got cubed units, or squared units. So the cubed and squared units means that we approach them just slightly differently, but it's really simple. It's the same as everything else, there's one slight change. So write down your given. And we're going to then write down the next set of units. So what unit will go on bottom of the fraction? Everybody?
Meters.
Meters what?
Cubed.
Meters cubed, because you actually have to replicate the same exact thing. And then what unit will go on top?
Centimeters cubed.
Centimeters cubed. So we actually do not know the relationship between meters cubed and centimeters cubed. We know the relationship between meters and centimeters, because we know that by drinking chocolate milk, sorry, by drinking chocolate milk, the relationship between meter, which is here, and centimeter, which is here, is what to what? What's the difference? 2 zeros, which to us means 100, okay? So you're saying 1 meter contains 100 centimeters. That's what you're saying here.
Yeah.
So I want to write that, but I see this cube stuff. So what we're going to do is pretend the cube's right there. So we're like, oh yeah, I got this. 1 meter, 100 centimeters, right? But then I, cube the units, right? So I also must cube the numbers. So if cubed units must cube numbers in conversion factor. That is like really the only extra thought we have to consider here. If you cube your units or square, you must cube or square the numbers in your conversion factor. So meters cubed and meters cubed cancel. Centimeter cube is the only thing remaining. Check. Okay, we met our final destination. And that is 8.004 times 10 to the 5th. No, 6 to the 4th. Can you guys tell me that in scientific notation? Oh, it's bigger than that one. 8? It's 8. I was working on it. And cubed. So it's like, basically you have the 800.4, and this ends up being 10 to the 6, because 100 cubed is 10 to the 6. So you move your decimal over 6 places. So, 1, 2, 6. So, in essence though, how many sig figs should I still have? There are 4 sig figs here, so I need 4 sig figs here, which in writing scientific notation, it's super easy to see the sig figs because they're in the very, very front. So there it is, 4 sig figs. So the only thing different here is that we're doing what as well? Using those numbers, and we're modifying them, either squaring or cubing. All right, so do number 2 for me with the person next to you. I guess that's a little. All right, check yourself, please. Okay, so I'm going to do you a favor. We can work on homework problem set 3B for a little while. And then the last maybe 10 minutes we'll work on our quiz, which I promised you. Okay? The reason I didn't forget about it is I've missed first, but I felt like we wanted to practice like just recognizing sig figs and round things a little bit more, so that it's kind of more, it's fresh. It's not just like first period, second period, pop quiz. Okay? So I try to take care of you where I can, but I'm still going to challenge you because you're in an honors chemistry class. So this stuff is what's on problem set 3B. There are also some word problems. Let me show you. Oh, and I love this. I'm going to show you this. It's going to be a lot of hard work, but we're in this together, okay? So on the problem set 3B, you have to show your work and your units because I give you the answer key at the bottom of the problem set. So every time you get something right, you pat yourself on the back. So it's affecting your back is sore once you've done this, okay? So we'll work on this for a little while. There are more practice problems on the lecture sheets that we've been working on, especially the word problems, and we'll try to approach some of those today, but I'm going to try to give you a break from me. So I'm going to show you where this is on my website. When you go to Honor Skim Documents and you hit Problem Sets All, you go to Problem Sets All and you'll scroll down to Problem Set not 3A, because we already did that one, Problem Set 3B. So I'm going to give you a quick tour. The first bit, general prefix conversions. After that, you get the complex ones, which is either squared, cubed, or multi-units. After that, there's a big, huge table of all these conversion factors. They're all densities, so I'll give you the units up here. And there's word problems that are involved. So what I'm going to do is ask for you to do, first off, you'll see that there's 9 here and 10 here, right? Mm-hmm. Let's start with half of the first set and half of the second set. We good? Mm-hmm. Do not just do the easy ones. Okay, try to mix it up so you're doing some different ones that are challenging here. So I'm going to leave that there because it's pretty easy to see, but if you wish to grab a laptop, you absolutely can. Okay? Work. Problem set 3B.
Is there a homework?
This is your, you'll see homework is first, or sorry, it doesn't say first half. This is half the problem set 3B, so we're trying to do about half of it right now. And whatever we don't finish, I'll ask you to. I don't always leave time in class for homework, but I'm trying to do better. It's my personal goal. So that's what we're working on right now. I'll make this a little bit bigger. So how many of the first one are you doing? Half. Now half of 9 is 4 1/2. You can do 4 or 5. And then in the second one, you're going to do 5. Alright, I'm taking this down. Hopefully you've written down the thing you needed, you're working on for the moment. I'm going to do the first 1 or 2 on the word problem side, which is the lower half of this. Ready? Try to give you warning. Did you write down what you need? I can put it back up in a second. Not the end of the world. But if you had earphones in or something, take those out for me. That's just respectful. Okay. So this is the table that was following those couple of questions we were working on, and these are the first couple of the word problems. So, just like we did in more, kind of towards the beginning of notes today, I gave you a full list of conversion factors, and then we're going to convert 3.55 milliliters of mercury to its mass. So, if you're looking at a word problem, you find your given. What is the given here? In number 1. 3.55. You're writing this down as number 1 for the word problem. So if you want to just leave some space, word problems, and then number 1. Okay, so 3.55 milliliters, and I'm going to put the symbol for mercury just to practice kind of our scientific symbols, Hg. So 3.55 milliliters of mercury. Do your conversion bar. Now we have all of these to choose from, but there's only one that works for us. Which one? Mercury, right? It's telling us we're dealing with mercury. We must use this for mercury. The units of this are what? Grams over centimeters cubed. So that's 13.6 grams per 1 centimeter cubed. That's actually what that's telling us. So, and knowing that I want to convert to mass, so what unit is asking for? Grams, right? Mass is talking about grams. That's the question here, right? So I'm in milliliters. Centimeters cubed and milliliters, those aren't the same thing, or are they? Are they comparable? Yeah, so yesterday we talked about this, and I kind of just wrote this down here as well. For water, we use this a lot, and I'm actually going to take water off because we are allowed to make that assumption because it's not grams. Let me put centimeters cubed here. We're allowed to make this assumption. 1 milliliter is approximately equivalent to 1 centimeter cubed because this is a volume unit and this is a volume unit, right? Right? So 1 milliliter, if I had 1 cube of a substance, and I measured it in volume, it would be 1 milliliter, and then if I measured it in cubic centimeters, it would be 1 cubic centimeter. So this is a conversion factor that you can use between two volume units that are like on that same scale, which are those. So here we go. We're going to write down 1 milliliter on the bottom because milliliters cancel, and 1 centimeter cubed on top. And that doesn't really do number changes for us. That just changes that to the correct unit, because in the end, now that milliliters have canceled, now I can see a similarity. I see centimeters cubed, and I see it up here as well in my mercury density. So do I want to take this and keep it as is, or do I want to take this and flip it to get to mass? Keep it as is, because what's on top? Grams, so I'm good to go. So here we go, 13.6 grams are on top, 1 centimeter cubed is on bottom, centimeters cubed canceled, grams it is, and that was what the question was asking for, and that's the only unit I have remaining. So 3.55 times 13.6 is 40 what? 40.28? 48.28, okay. 48.28 grams, and then how many sig figs should I likely have? 3, so this would be 48.3 grams. So, I told you kind of half of the top section. My goal is for you to attempt half of the word problems. I don't have them all up here right now because I felt it was easier to start with the first section because that's, you know, starting off easier ones. But tomorrow I can take some very detailed questions on some of the word problems, but you have to sit and look at them on your own some. And then you'll notice so half of this is going to be due tomorrow, and then the next half will be due Thursday. If you want to get ahead, you can get ahead, but you've got other things you're doing tonight. So you have your ed puzzle, which is actually a short one. Oh, before I move on from there, open up your folders. And I don't always print your stuff for you, but I did for the first unit. Pull out this. So the video for tonight, I think it's like 7 to 10 minutes. It's a lot shorter than the first one. The first one was a long one. But it talks about matter, and so you see the first half of this. These are the two most important slides I printed for you. There are more slides that I go over, but you can always annotate things on that. And then the last video for this unit, which is like in 2 days maybe, so this is the bottom half from chemical and changes. So I just want to let you know that you could like, you put this out and put this in your notes, and you can take notes on it. But I wanted to print out like the tables and like diagrams for you because I thought it was valuable for your process. Okay. So that's what you got for tonight. All right, we're gonna go ahead and grab laptops. Okay, everybody go grab laptops. Your laptop, by the way. First half, you kind of guys are on that side, so grab yours first. Grab your laptop. And then second half, guys, go ahead and grab your laptop.